Hi friends, today we are gonna do the challenge lab in Amazon SageMaker. First of all, let me define what is the problem and what we are gonna try to manage. So we are working for a travel booking website, and that company wants to improve the user experience, customer experience for flights that were delayed. So we are gonna trying to determine delayed flights. So for that, we are taking a data set by US Office of Airline Information, and actually we are taking lots of data sets. And let me start with the problem formulation and the data collection. So for the first question, determine if and why machine learning is an appropriate solution to deploy for this scenario. So if we can solve this problem by using the traditional methods, we should do that, because the machine learning will comes with much cost, because machine learning will require to obtain the data. So we can either obtain our data by ourselves. It's actually really hard, or we need to buy this data from somewhere else. So the traditional ways will be more cost effective, and for actually the problem may be not solving with traditional methods, but it can also maybe could not be solved with machine learning, because in machine learning data is so important. So the clarity of the data, for example, or can we obtain the data for solving this problem? These are the important things. And in this scenario, we can use machine learning because we have data, lots of data, to train our model and test our model. And this data is appropriate for our works in here. So formulating the business problem. So while formulating the business problem is determining the delayed flight. So we need to find which flights will delay. To find that, we are gonna use the binary classification methods. After a time, it will be delayed. We are gonna say that after, for example, after 20 minutes delayed, it will be delayed class. And identify the type of ML problem that you are working with. So we are gonna do classification in that case. Also, for example, in some cases we can use reinforcement learning methods. It bases on reward and punishments, and if the output data should be consisting of like instructions or something else, we would use that. Or if the data is continuous, we can use logistic regression or some clustering algorithms. In that case, we are gonna use a categorical, which will be a binary classification. And now analyze the appropriateness of data that you are working with. So we are taking data from somewhere else, and I think it could be the government, and the data are clear, and it is relevant to our problem to solve. Now, let me start with setting our project. So let me import the needed libraries for us. Now, data processing and visualizations. So what can you deduce from the basic statistic that you are run on features? What can you deduce from the distribution of the target classes? Is there anything else you can deduce by exploring data? So to answer these, I'm gonna just run these blocks. And now we are gonna upload the zip file from that locations, and after we take these zip files, we are gonna extract them and use a CSV file. Now it will take a little bit of time, so I think it's done. Now we are gonna extract the zip files by running this cut. So I think I should run here first. Yeah, now we can run here. Yeah, now it's extracting the zip file. For example, it's I think the November 2016, and this should be February 2015. This here. So we are gonna just open this CSV file. After this zip file, I think it's extracted 2018 September. Is that here? We don't need to wait. Actually, it's already done for all the years and all the months. No, it's still continue, but we cannot. I think we can continue. So let me read this CSV files. Yeah, data capacity. So I think these are our attributes, which is in the data set. Yeah, I think that. So this is the long term of this short words. So air delay is difference in minutes between scheduled and actually arrived time. So air delay 15 is array delay indicator. Oh, So this attribute will be an indicator to find which plane is delayed or not, which airplane is delayed or not. So after 15 minutes, we are gonna say that it will be delayed. So we predict the time, and we are uh, with the prediction, we are gonna say the customers this flight will be uh, delayed. Now I think the extraction is already done, so let me continue from here. Now we create a data frame. Let me run, and now what is one thing? So print the row and column like in the data sets. So we can actually do this by df10 dot shape. So I think after I run this, we're gonna give us, yeah, so this much samples we have, and the columns are 110, and this much sample we have in the CSV file. Now it's asking for printing the first 10 rows. To do that, we're gonna say df10 dot add, and for the first 10 rows we use this. When I run this, actually Steve 10, yeah, as you can see, these are the first 10 samples and the CSV file. So you can see the columns in here. These are the columns, and these are actually the null variable. I think that. Now let me continue. Print all the columns in the dataset to read the column names. So for that, we're gonna change the code from here. So we're gonna say df10 dot columns and print col. So when I run this, yeah, now you can see the every column in this CSV file. These are the attributes, and it's written 110, 109. These are the column names. Now let me continue. So print all the columns in the dataset that contain the word del. So for delayed and for the columns which is containing del. So to find it, it actually gives a sample code in here. So let me just paste in here. So x for x in, we're gonna change in here. We have 10 columns, and if condition will be now if del is uppercase, if del in x. Now when I run this, it brings the every attributes, every columns which contains the del. So these are the attributes, and here are some more questions to help you learn more about your datasets. So how many rows and columns does the dataset have? How many years included the dataset? So to learn that, we are gonna use these codes here. So to show the rows we are gonna use if temp dot shape, and we're gonna square bracket 0. So for the columns, we're gonna use this one and the year in this data set. So we can use unique in here if temp dot if temp that year, the column name, and the unique at the end of it. So for the months, we're gonna do the same thing. So let me copy this and paste here, and we're gonna change this month. Now, year and month, these are capital, and in here the data range. So to find the data range, we are gonna use for the range, we are gonna use which column. So we are gonna use flight date. Yeah, flight date is unique. The flight dates. That's unique. So it will be the same for the maximum. And now the airlines covered in this dataset are for the airlines. We are gonna use if temp reporting airline that unique. If temp that's airline that's unique. And for the origin, we are going to use origin. So let me just copy this. And for the unique, we list so copy origin, and here list list should be parentheses in here, and for the destination it should be test. We checked it here. Yeah, origin for test. Yeah, now let me run this with some errors. Yeah, it gives an error in airline, so I should check airline. So it was, let me try that. Origin, is there any brackets? I don't think so. Let me just check it again. Yeah, actually it's in here, so I can take from here and use it in here. Now when I run this, it will not give an error. So yes, now it gives the how many rows and columns in here. So we have this much sample, so we have this much rows and this much columns to represent the attributes. So the year in this dataset are just containing 2018 because we just took the CSV file which is in September 2018, and the airlines covered in this dataset are these ones, and the origin airports covered are these, and the destination airports are covered in these. Now, what is the count of all the origin and destination airports? So to find it, we are using values count. So we are gonna just say that bf10 dot origin dot values count. We should take square brackets. I think not square brackets. Should say this syntax. For the destination, we are going to use test. Now let me run this. Maybe I did something wrong. Yeah, I did something wrong. So value const b. Yeah, actually it's wrong in here. Is this syntax is wrong. I just fixed. Now you can see from Abbey we have this much origin and this much destination in this data set, and ABQ also. It gives the count of all the origin and destination airports. Now let me continue from here. Print the top 15 origin and destination airport based on the number of flights in the dataset. And now here count sort values by, that will be by and square brackets, and here we're gonna say the origin, and for here we're gonna say the test. Now when I run this, it will be destination. When I run this, you can see the first 50 airlines, and the order is not ascending, descending order, so it shows the much higher. Let me continue from here. Even though information in the flight can you predict if it will be delayed. So as I mentioned earlier, we are going to use this attribute to find if the flight trip is late or not. So So now what we are gonna do, we are gonna combine all the CSV files. To do that, we use this code in here. And we are gonna run this code. Now let me run this code, this one, and this one. Now this process will take 5 to 7 minutes, so I'm gonna just stop the record to wait. Hi, I'm back. So it takes about 5 minutes to merge all the CSV files, and I have run this block to show the first 5 records, and these are in here. And now here is more questions. So we repeated the same things what we have done with the CSV file, which belongs to September 2018. Now we are going to do that for all the CSV files, and we combine all the data from a data variable, data frame, with using pandas. Now now when I want to find all the rows and columns, to find the rows we are gonna say data.shape square brackets 0. For the columns we are gonna use the data.shape square brackets 1. So it will print us so it will run all the blocks. So I'm gonna just need to go on. Now to make a year, we are gonna say data.year.unique. And it will list all the years in our data. Now for the months, it will gonna sort the months and give a list of the months. So I'll just replace year with month, and we are gonna just replace here with data dot, which I forget what was that, so we need to check it again. So flight date and reporting airline, which I just copy. It's here, and just copy it here. That's unique. Now find the max. I'm gonna write the same. Maybe that's report airlines. And for that, for here we say origin, and for here we say test. So when I run that, so it's it was different. So reporting airline. Now when I run this, working airlines. Yeah, now it gives almost 1.5 millions of samples and 20 columns, which is our attributes, and the year is now. I just sort this one as well. Sort, and now when I run this, the years starting from 2014 and 2018, and the months are covered, all the months in a year. So in the previous CSV file, we just looked data in September in 2018. Now the data range for data is 2014, starting from 2014 and finishing to 2000 at the end of 2018. And airlines covered are these ones, and the origins are that ones, and destination airports covered are these ones. Now we define our target is delay instead of RDL 50. So to rename these ones, we're gonna use this, and we're gonna change here like that, and we make them as delay. Now when I run this, I think now it should show the, instead of RDL 50, it will show is delay. Let me just check in here. I'll run the code later. Just check it here, data.columns, so you can see that. Now, as you can see, we change the name. Now, for detection of the null variables, we use isNull, and we sum them up. How many of them is null? And for that, we're gonna use this calc. This df data frame is just data. Now when I run this, and as you can see, the 22,000 of the data are null for air delay minutes. So when we compare this much of data out of this, so it's almost 1.3% of data. So we can either remove or input these rows. So in this case, we are gonna remove null columns. When I run this, we are gonna remove these columns, and it will gonna be 0, I think. Yeah, as you can see, it's now 0 because we have erased these data. Now data that are get the hour of data from the hour time format. So we change the time format in here. I run this. Now we are gonna do some data exploration and check class delay versus no delay. So let me run just this. Now, as you can see, the data we have, it shows that almost 8% of the data is not delayed, consisting of not delayed, and almost 20% of data is consisting of delayed examples. Now, what can you do this for the part ratio So I have mentioned already. Now let me run this. So what a new data, I think. Yeah, it's showing here. So it will give more information about the data. So as we can see now, we can see the is late by looking the month, in which month is late is much higher, and in the what time is late is being much high. And for example, in here the June is, if we look the percentage of is late most higher in a year of month, so it will be June. It could be either, I think it could be causing for holidays. In summer it's high, and also in semester location. So let me just continue. Now let me run this. I think, yeah, now we can see that now by looking at these data, it shows the distance and its delay. So yeah, now the distance in the flight trip is not it's not correlated with the is delay, because it's like overlapping. When I shift this here, it's almost overlapping. So actually there are questions in here: which months have the most days? So June. What time of the day has the most days? So what time of the day? So it should be 8 p.m. Let me check again. Yeah, it's 8 p.m. And what day of the week has the most days? So check the weeks. So as Tuesday, Thursday, and Monday and Friday, I think. Yeah, as so much close to each other. As it's not a good correlation. And which airline has the most delays? So the OO and WN is has the most delay. The DL is the least in these datas. Which origin and destination airports have the most delays? So it's given origin. So O or D as most delay, and in here SFO. Now, is flight distance a factor in the delays? No, it is not, because there is no correlation between the distance and the use delay, because it's overlapping. If it could be, for example, uh, after 1.5 thousand, if it's not uh, the not is delayed variables would be in here, we can say that after this much of distance, it should always delay. So actually there is no correlation in this data. So continue from here. So enter your answers. I already explained our answers by saying. So look at all the columns and what they specify. So let me just run this. So these are our columns, and when we look at the data types, these are integers and these are objects, and these are floats, etc. So filtering the required columns. So I think we are gonna do in here one hot encoding. as mentioned, yeah, it's already mentioned in here. If you need to do one hot encoding of this variable, it will result in 23 more counts. So it should be the hours when we apply one hot encoding to hours in a day. It should use the 1, 2, 3, 4, 5 to reach the 24. So to change the column type category, we use S-type function. Now let me just run this code. Now for data dummies, fun.get dummies. So in here we are gonna take data, and data should be this one. I think I can take this one, and would be like that. And the concatenation will be the consisting of data dummies and data. So I'll just replace them by data and data dummies. I hope I'm doing well. So, and when I run this, let me just first run that one. Yeah, and after that one. Yeah, I think it's work. Now use the shape and column. So now to check that, we're gonna use data.shape and data.columns. Let me just run here first. Now, as you can see, now we have 4 columns and this much of samples. Now we're gonna check the data columns. We're gonna check the columns for these 4 columns. Columns. I don't remember. Yeah. So display distance is delay. Now this. You are now ready to train the model. Before you split the data, rename this delay to column target. Function for the categorical columns. So I need to take this one instead of that. I should keep this. Now we are gonna do the same things. What's my wrong in here? So I did a mistake in here. I should replace the what I have done before again. And this, and when I run this, it's work. Actually, it's work. I do not do the same things again. I think. I hope. I hope it will not cause any errors. I hope that. Now we are gonna rename the same operation again. So here's delay to what? And delay to what? Targets. I'm gonna say it's targets. Now when I run this, yeah, it works fine. Now that's the end of step 2. Now it says that choose to download save file. So I'm just gonna download this. Yeah, in here. So I can download it. Now step 3, model training and evaluation. Now what we are gonna do, we are gonna do the separate our data training and test and validation. So for that we are gonna use scikit-learn model selection. We're gonna use scikit-learn, and in here from scikit-learn model selection import train test split. So we are gonna split our data, and while splitting the data we are gonna use the 20% of the validate and test. We are gonna use the 20% of data for validation and test, and the rest of the 80% of data for training. And this 20% of data we are gonna also split them by half, and in totally 1% of 10% of data will be validation and 10% of data will be tested. Now train and validate this data. Now in here we are gonna print the value counts, and it should give sample answer in here. So let me just run here. Yeah. Now when I run here, so what's my run key here? Going to this, I'm gonna put full file. This can be either CSV file. So I think it should be working fine, and it should be the sample answer like this, and the sample answer should be the same percentage of the same person that consists of same percentage of the is delayed. For example, the percentage of is delayed in here and in here would be same also in here when we look at total data. Now what the error is in here. So I'm gonna just stop the record. Let's try to find the error, and if I could find, I'm gonna continue. Hi, welcome back, and now I have fixed the bug. It should be causing the performance here because I did a mistake in here while doing one-hot coding, and these are the columns after one-hot coding, and we dropped the categorical columns in here, and I make a mistake during the giving this dummies. Now let me continue from here. As I mentioned, we split our data, and the percentage of the training set and test set will be the equal by the target. So as you can see, the percentage is the same. Now this sample answer, and star output. Now we are gonna continue from here. In here we are creating an estimator object, and it gives a sample count in here. So instance type, instance count will be 1 in our case. How many instances will occur? If it will be more than 1, it will be parallel, and this the instance type which we have initially choose for this notebook. And predicate type is a binary classifier, as I mentioned. We are trying to find is it late or not, and just for example purpose. Now let me continue from here. We'll just run all of them. So for this one it should be string and term. And now it should run well. Okay, now we create records. We create channel, which is a train, validation, and test. Now we are going to use the fit method to train our models. Now sample code is given to us, so instead of linear, we are gonna use this estimator. So now when I run this, I should first run here and run this. Now it will run, and in this model evaluation we are gonna evaluate our trained model. So first it needs to be trained. Let me check training. So let me check here. Time. So now it should be training our data in training job as in progress. Yeah, in here, and yeah, it's time I've been creating. Now in model evaluation, I'll just finish the training is done and go on from here. Let's just stop the record. Now I think I have created twice, and I hope it will not be a problem. And now I'm gonna continue from the top. Now in here we are gonna do model evaluation. Let me just run that. It's not working now because the training is not ready. In here we are gonna replace LabBucket name with the name of LabBucket that was created during the lab setup. So this will be in S3 bucket. So go to AWS Management Console and click this S3, and from here, yeah, as seen in here, this is the time, and click this one and take this, copy, and come to here and paste it here and remove the comment. Now it should work. Let's check the trading again. So it's still in progress. So I think it will take about the same time. So that will take 5 minutes. I know. So I will just stop the recording. Now it finished the training, and I have rerun these code blocks again and again. So therefore it creates so much training job, and I stopped three of them, and that's why it took so much time. Now I hope we are gonna continue for the we're gonna continue from here by testing our data, and in testing I have already shown how to change here, and let me run here now. Now in here we are gonna use batch data. If it should be update, we will sending just one data, but now we are sending a batch of data to test our model is working or not. Now let me run this. Now run here. No, I think it should be in inference, and from here endpoint configuration. No, that's not. So the buckets, we are doing the testing in a different location, because for the testing our data, the computation power is not so much high compared to training data. That's why we are testing and validating our data in a different location. Now let me go from here. When I run it, it will not gonna show, because it needs to finish this job before. So we are gonna wait. I don't know how much time we wait. I will just again stop the record. Actually, I think we are not gonna need to wait. It's already done. I don't know, but we are gonna use these functions and this plot rock functions in here to plot confusion matrix. We are just gonna call the function in here, and we send it the parameters. So one parameters is this, and the other one is that one. Now when we run them, it should now plot the confusion matrix. So first plot this function, first run this function and the other function, and then run this column and this column here. So some parameters. Right. So actually we are gonna need to wait, and it should be in batch transfer jobs. Now it's in progress. When we click that, we can see more detail. But for example, which path is data are stored in here, and instance type, the instance count we can see in here. So it will gonna end soon. Now we have done, and we have declared the plot confusion matrix function and plot receiver operating characteristic function, and I have plotted in here. In here it shows us from here this is the true not delayed, and this is false not delayed, and this is true delayed, this is the false delayed. And when we look at sensitivity, specificity, and precision, and false negative rate, false positive rate, and accuracy. And accuracy is the false positive, true positive, and true positive, and true negative over all the data, and is finding like that. And how does your model performance on test set compare its performance on training sets? What can you please from comparison? So training is more hard, and it takes so much time compared with the test sets. Are there obvious differences between the outcomes metrics like accuracy, precision, and recall? If so, why might we be seeing those differences? So it could be about, for example, let me give you an example, and it could be about some detection of cancer, and in 1000 people data, just 5 people are not cancer, and we are saying that if we say that nobody is cancerous here. Everybody is healthy. The accuracy of the data would be almost 99% and higher than, so 99.9%. So is this a good model for us? Is the good trained model? So no. So we need to look precision. Look, precision is not good. If we look to precision, what I give you the example, it would be 0, because we didn't know just one cancer. We couldn't find one cancer. So precision would be 0. So there are some formulas to find them, and this is not a good model for us. We can find a better model. Stir Y. So for us, I think precision should be more higher than what we expected, because in here we predicted actually not well, because Y precision is more important, because we are gonna try to find if the flight will delay or not. So it is not gonna give us this ability now. So now we are gonna go to step 4, feature engineering. So in feature engineering, we can how might the balance of your swimming cost and improve motor performance? Do you have any features that are correlated at this stage? Could you perform any feature reduction techniques that might have positive impact after performing some features? So now we are gonna add 2 new features, and the first one will be holidays, and second one is weather. And because the list of holidays from 2014 to 2018 is known, you can create an indicator reliability holiday. So we're gonna create an indicator which will be this holiday. Let me run here. Before we run here, we are gonna using here the numpy. So we're gonna be np sin and the rest of them will be like that. Now let me run this. Now let me run that. It's downloaded. I'm gonna continue. Now, so we will check the missing values in here and print the index of person. To find the roster using use the SQL function, then to get the index, use the list on the index value. So I'm just gonna take this copy and okay, I can do stuff. Just okay. Now for here, we're gonna say max, and for here I'm gonna say now run this. It gives this result. Now we are going to put y. We're going to use goodbye. Yeah, I forget the code in here, and so we are gonna goodbye London station. I think should be like that. I'm not sure. Let me try. Yeah, like that. Now merge the mean data with the weather data, and we are going to check the missing values again. Now it's all 0. And now we are gonna group some columns. Add the origin weather conditions, and as always, good to press check for those. So I'm gonna check. I'm gonna do this convert. So we are gonna convert the categorical data to numerical data as we did earlier with using S type. Now data type means data near part amount. Everything is the same on here and here. The shape, so this many samples we have and this many columns on here. So these are our columns. Now we are gonna rename this delay with target. So we're gonna just save it as delay and target, and run it. Now we are gonna use the split split data methods. So train, validate, test, and split data. So I'm gonna say the train, validate, and test equals splits data, and which was data and train target counts. So train, let me print them out, print train, and square brackets and targets, train target dot value counts. So should be same for the others. So I'll just take this test and make this validation. Let me check them. I hope it will gonna give no error. So it gives error in validation. So validate valid. So we're gonna be like that. Sorry for that. And now it gives the same we had it before. Now so now see if these new features add any predicted power to model. So it needs to give up predict power because we the earlier features is didn't work, and now we are gonna give some new features to predict better. So in here I'm gonna just take here, copy and paste here. I think it should be like that. We create and classify estimated 2, and when I run that I could use that. I hope there is nothing wrong. When I run here, yeah. Now train your model by using 3 datasets that you just create. So to create to train our model, we first take this one and that fit, and after fit we are gonna set the parameters train records, value records, and test records, and these are gonna be in a square brackets. Just I forget it, and yeah, square brackets in here. So now when I run that, it needs to train. It needs to create a train job. Let me check. When I come here, training jobs, yeah, there is a training job in progress. So let me wait for this. Now we have trained our data. Now we are gonna test it by using classifier enter2, and run this, and it will take also sometimes. Now we have tested our model, and now we are gonna plot the confusion matrix again, and it gives almost the same earlier. So I'll run that one, and specifically precision also same. Accuracy is about 80%. Let me check the earlier precision. So in earlier precision was much higher than this one, and sensitivity is 0.5. So let me check also sensitivity. Sensitivity is 5.7, but this is not as good as we want. It's actually almost same the earlier. So now what we are gonna do, we are gonna try the XGBoost model this time. So first we have upload our files to S3 buckets. And we have a train channel. We have create train channel, validate channel, and we are gonna combine this channel in a data channel. And we are gonna retrieve the XGBoost model from the container. XGBoost image from the container. Now here we have again create an estimator. We give the parameters and we set the hyperparameters in here. As you can see, on this. Now we will use the batch transform for our new model and evaluate the model on the dataset. So and upload this batch X file and run it. This one. And XGB transformer weightless. So this gives asynchronous programming. So until these are done, do not do anything and go to here. So let me run here. Now these are gonna be run. After that training is done, it will be executed. So let me wait. And at that time I'm gonna explain what this threshold means. In this threshold, so the return the predicted target will return as a score, and this score will be between 0 and 1, for example. And we are gonna change this binary classification. So we say that if this score is greater than 0.55, it will return 1, and if it is less than 0.55, it will return 0. What that means and what is and how it affects our model or our job. So again, I'm gonna give the same example. For example, you want to detect cancer people. When you increase this threshold, it means that, for example, it will return a score 0.8, and you make this threshold 9. So if a person is like if a person would be 7.5, 8.5, it it's gonna probably be a cancer patient, but you're gonna saying that you're not cancer. But when we say someone you're cancer, it's 100% cancer. There's no way to that person not to be a cancer. But when we decrease this threshold too much, for example 0.3, now for example a person with score 0.4 comes to us, and we have said that you're not we have said that mm, we have said that you are not cancer. uh, yeah, it will actually the reverse I have explained. And if we are saying you are cancer, not the reverse, I'm sorry, I was correct. uh, you are saying you are cancer, but this person is actually not cancer, so we are applying this person chemotherapy. So it depends the change this threshold, depends the situation itself, what we want to get, what we try to accomplish. So we give we choose this threshold to what we want to accomplish. Now it's stop on here, so I'm gonna just stop in here and wait. Now it is done. Now time to test our trained model. So we're gonna run here, and run here actually it has red run before. Now I am waiting for the finish this process, and after that I'm gonna plot the confusion matrix again, plot the this fork graph fork chart, and after that we are gonna do hyperparameter optimizations, and after that will be the our end of the log. So you're gonna ask this question: how much did your amount improve as you changed your dataset? Sure. Let's build it. What were some biggest challenges you encountered at this point? So the most important things, I think, how you're gonna evaluate the model. I mean, uh, as a being data scientist, it's important to choose the features, which features you're gonna choose, and which models you're gonna use, and how to test, how to tune your model again. This is the most important things, I think. And after is hyperparameter hyperparameter optimization, and the result of this I'm gonna explain. I'm gonna answer this question, and I'm also gonna answer this question. So for me, the biggest challenge, I think, in feature engineering, and I learned some new Python comments which I have not known before. So it was hard for me to learn Python methods, some methods. So there's no question. And in report, I'm gonna give more detail about these questions. In report 5, not writing. So I'm gonna wait a little bit more. Let me stop the report. So it's done. Now we have got predicted target and test labels from S3 S3 bucket. And let me run this code, and in here we are converting the sky as a binary result 0 or 1. As you can see, these all of them are lower than 0.55, so these are 0, so target is 0, so that means that not delayed. So now I'm gonna plot the confusion matrix in here, and plot the node in here. Now, as you can see in here, in this case, precision is being more high, what we expected, and accuracy is also good. So, and the sensitivity is also good, which was 0.55, and now this time is 9. So this using XGBoost algorithm is improved our model. So yeah, how well model handled tested, what can you conclude? So I have already concluded now. That's the best what we have done to now. Now we are gonna do hyperparameter optimizations. Let me run this. And after this, we are gonna run that. And to see that we can go to here, and after here we are gonna go to until 3 hyperparameter tuning jobs. So now we can see that in here as in progress. Wait until the training job is finished. It might take it will take so much time, and information about the training job. So I want to wait for it. So I'm gonna wait. Okay. Now it's completed. So we have tried to find the best hyperparameters. Now we're gonna run this log, and after that we're gonna run this blog. now use the estimator and train by using the data. So this best estimator here, and use fit method. Just run. I have wrote this code, so it's gonna take some time. It's in progress. Let's see. Now we have trained our model, so we are gonna test with page transform, and now we will run this code, and this will prepare us for the test. Let me wait for it. And now it has done, and we are gonna get the confusion plot, and as you can see, targets are in here. Targets are not light, and we are gonna get the confusion plot. I think it's much better. Let me plot this one also. Yeah, as you can see, as actually it needs to give better, but in my cases it gives not so much better. I don't know why. It should be more higher than the sensitivity and this precision. I think it should be maybe 80% of precision, and sensitivity need to be more higher than the before. Maybe I did something wrong